Welcome. In this video, we'll continue with some more applications with right triangles. Let's first take a look at the definition of angles of depression and angles of elevation. So an angle measured from the horizontal up is called an angle of elevation. So we can see that angle of elevation here on the right. From a horizontal line angled upwards, that would be angle of elevation. An angle measured from the horizontal down is called an angle of depression. So in general, our angles of depression will look like the one on the left here. So these certainly can be flipped around, but the angle is always going down, or you could think angles of depression look like negative angles, and angles of elevation would look like positive angles. So let's take a look at an example of a right triangle with an angle of depression. In this example, we have a man climbs 213 meters up the side of a pyramid and finds the angle of depression to his starting point is 52.6 degrees. How high off the ground is he? So in this case, we'll just have the picture here, and we'll just talk through the picture of this. So if I'm at the top of this pyramid and I think about the angle of depression towards my starting point, this would be again the angle of depression. There's my horizontal, and the angle of depression is going back down to the really the line vector that goes back to my starting point. So that was my current spot, that's my start. And so there's a angle of depression here of 52.6 degrees that is going down below the horizontal. And so if I wanted to find the height at this point, really we're thinking about the altitude of this triangle. And so when I consider the altitude of this triangle, these two measures, x here and x here, are the same length. And so we can consider finding this with the trig function again. In relation to my angle, I still have a right triangle here. And so I want to go out and solve for the opposite side when I know the hypotenuse and an angle. And so again, here we can use the sine function. We can say that the sine of our angle 52.6 degrees is equal to the opposite side, that's x, divided by my hypotenuse of 213. If I multiply 213 on both sides, I can go and solve for my value of x. And for us, x, if we take a look at putting this into our calculator with our sine function of 52.6 degrees, we'll find that this is going to be 169.21. Again, make sure that our calculator is in degree mode here. So this will be our height of our pyramid, and this would be in meters. Let's take a look at a second example here with some directional angles. So here a boat travels on a course bearing north 52.5 degrees east for a distance of 238 miles. How many miles north and how many miles east has the boat traveled? So in this case, we have a picture, and we'll do one example to just draw the picture from scratch. But let's just consider the language first and look through the picture. If I have an angle that is north 52.5 degrees east, when I think about drawing this, I want to start at my first directional point, that would be north, And I'm going to be drawing this angle 52.5 degrees to the east. And so we'll notice in our picture, if we start kind of our pencil at our cardinal direction of north and bring our angle 52.5 degrees to the east, this will make our picture of the traveling boat. And again, this vector out from the origin, you could say, is 238 miles. So again, we're creating a right triangle here in our second quadrant, looks like. And so we have a right triangle, 52.5 degrees is our angle. We know that the opposite side to this angle is x, and again, my hypotenuse is 238. So if I'm going for the distance I've traveled east, I can consider that first, the direction I've gone east. We can consider solving for x here using our sine function. So I know that the sine of 52.5 degrees is equal to, here, x divided by my hypotenuse, which is the distance, 238. All right, we can multiply by that distance on both sides, so 238. And we can solve for that x. So here, x, the distance that I've gone east, 238 sine of 52.5 degrees. If we put this in our calculator again in terms of degrees, we'll find this to be approximately 189 miles east. Now we can consider how far if we actually traveled north. That would be the y variable. We'll do that in blue. So if I wanted to solve for y, I know I can use that same angle, 52.5, and now I'm going to use the cosine since this is the adjacent side. So I have adjacent side. I still know my hypotenuse, so the cosine function works great. So I have the cosine of 52.5 is equal to the y side, the adjacent, over the hypotenuse. And again, we can go and multiply by 238. On both sides. So if I have y equal to 238, and we'll take just the cosine of 52.5 degrees, we can find this is going to be 145 miles north. So these would be our two directions, north and south, for this specific vector going 238 miles in the direction north, 52.5 degrees east. Now, let's just practice maybe writing another angle on this board and naming it. If I was to write an angle here, maybe in the southwest direction, and we'll call this 25 degrees here, and we'll just give it 108 miles. If I wanted to talk about kind of how to name this angle, one way we could name this angle would be, if we start in our south direction, we could call this south, S. If I wanted to go from south, this would go to the west direction. And so really the angle created here, that's 25 on the upper side of that vector. This would have to be a 65 degrees. So we could call this south 65 degrees west. So S 65 degrees W. So if I started on the south cardinal direction, I go 65 degrees in the western direction, and that would be my direction. So I hope this helps with some of these directional applications, as well as angles of depression and angles of elevation. I'll see you in the next video.